Alright, hi guys. Today I'm going to be going over lesson 6.4, which is about inverse functions of specifically square roots and cube roots, what we've been talking about. So, first thing we're going to do is we're going to think of this word inverse. We're going to relate it to ideas that we already understand. So, inverse, I like to think of the words reverse, maybe flip. I've heard the word opposite a lot of the time. So those are the words that we're going to keep in mind. And now, if we think of a reverse function, the opposite of that function, let's wonder how that looks like mathematically or graphically. And we're going to do that using an example. So the graph of f of x is equal to x squared plus 2. And that is going to be shown below. And what we have to do is we have to find the inverse of f of x, which f of x is this thing right here on the graph. And we're going to need to graph it as well as put a table on it, make a table. So looking at all this, what we're going to do first is we're going to find the points of f of x is equal to x squared plus 2. And we're going to do that using this table right here. So whenever x is negative 2, what is going to be my f of x? We see right here we have a value of 6. Whenever x is equal to negative 1, we have a value of 3 for our function. Whenever x is equal to 0, we have a value of 2. And then for the other two values, 3 and 6 because of symmetry. Now, whenever we have an inverse, that means we are going to flip the x and y's. We've gone over this many times, especially in Unit 1. But inverse basically means flipping the x's and y's. So that means the first column is going to be my f of x's, my y values. Oops, it looks ugly in that color. Let me change it. And then my second column is going to be my x's. But even though I labeled it like that, we're still going to consider this the domain and this the range. The same way that it was the domain over here and the range over here. So now that we have this, we just have to look at the graph, the table that we made before. Just put in all the values that we did before. So before we had 6, 3, 2, 3, 6. That means we have that for our x values now, for the inverse. And similarly, we have values x is equal to negative 2, negative 1, 0, 1, 2 for our range. And if we plot all of these points, we're going to end up with a shape like this on the graph. So 6, negative 2 is going to be somewhere here. 3, negative 1 is going to be right here. 2, 0, 3, 1, and then 6, 2. So far that looks pretty good. We just flipped the points. Now we have to ask ourselves, is this the inverse function? And the answer is no, it's not. Even though we did flip the x's and the y's, we have a problem. Fails the vertical line test in a lot of different spots. So that means that we have to make an adjustment so that we could have a function. And that adjustment is we eliminate this bottom part. We only have this part up top. This is essentially going to be our inverse function. Now this process is very easy to do if we have a graph like this, but what if we didn't have a graph? What if all we had was the function like this? How would we do it? How would we figure out how to do it? Is there a method or something? And the method would be what's right here. Have it right in front of us. So we just have to follow these steps and trust in our algebra to solve for the inverse algebraically. So step 1, we're going to replace f of x with y. So if before our f of x is equal to x squared plus 2, we're now going to have, let me write it in blue, y is equal to x squared plus 2. So that is step 1 done. Now step 2, we're going to switch the x's and the y's. So that means we're going to switch the places of these variables. Wherever y was, now that is where we want x. Wherever x was, that is where we have y. So that is step 2 done. Now step 3, we're going to solve for y. Meaning whatever y is, wherever y is, we want it by itself. So if we have this squared plus 2 on one side, we want to first subtract that 2 to get the y closer to being by itself. So once we subtract 2 to both sides, because you need to respect the equality of the equation, we're going to end up with something like this. X minus 2 is equal to y squared. Now that we have this, I want to find the square root of both sides, because the square root is opposite of squared, and if we do the square root, then the squared is going to cancel out on the y, and that means we're just going to have y on one side. So that means we're going to have y is equal to the square root of x minus 2. And that is going to be our answer. Now for the domain and range, we need to first look at our graphs to see how they change. Or just to see how far they extend. So the x squared plus 2, which is this one, goes forever to the left, forever to the right. So that means we have a domain of negative infinity to positive infinity. The lowest point is going to be 2. And the highest point is going to be, let's see, infinity. It goes up forever. Now the domain and range of the inverse, if we look at it, the furthest point is going to be 2 for the left, and then it's going to go off to the right to infinity. And now if we look at the range, the lowest point is going to be 0 because it starts on the x-axis. Then it goes upwards forever to infinity. And now we notice is that the range of the function and the domain of the inverse are the same. But that is not true for the domain of the function and the range of the inverse. And the reason that is because we had to chop off the bottom part of the function. So what we're going to say is that the f of x domain differs from the f inverse range. And the reason this happens is from the adjustment. This comes from the inverse adjustment. So I'm just going to write the f inverse of x adjustment. Okay, so we'll see if we get more comfortable with this idea as we go on. But anyways, let's check it out. So let's create a table for f of x is equal to 2x cubed minus 1. So we're going to plug in each of these x's to see what values of f of x we get. So whenever we plug in a negative 2 in here, that means we're going to end up with something like this. 2 cubed minus 1. So negative 2 cubed is going to be negative 8. Negative 8 times that 2 in the front is negative 16. And then negative 16 minus 1 is negative 17. So if we plug in negative 1 now, that means we're going to have negative 1 cubed, which is negative 1, times 2, which is negative 2, minus 1 is negative 3. If we plug in 0, that one looks easy. We have 0 cubed, which is 0, times 2, which is 0, minus 1, we get minus 1. And now, what happens when we plug in 1 cubed? 1 cubed is 1, times 2 is 2, minus 1 is 1. And finally, when we plug in that 2, we're going to get 2 to the third power, which is 8, times the 2 in the front, which is 16, minus 1, which is 15. So we're going to do the exact same thing. We're going to flip the x's and y's. So now we have f of x in the first column, f of x, and then the x is in the second column. But still making sure that it is domain and range respectively. Whoops, I think I made a mistake. So yeah, so it should be -17, and then -3, and then -1, 1, and then 15. We should also have -2, -1, 0, 1, and then 2. And the way that this is going to look like is, well, let's graph it to see how it'll look. So we have -2 all the way out there. We don't really have that many points to plot, but we're just going to try our best to see how it looks like. 0, -1, and then we have 1, and then 1, 2, 15. So it's going to look something like this. Now for our inverse function, we're going to have -17 and -2. We can't plot that one. -3 and -1. We have it right here. -1 and 0, and then we have 1 and 1. So we're going to end up with something like that, like this. So that looks pretty good. And we still notice this phenomenon of having symmetry about the y equals x line down the middle. So we found the inverse using a table of values. But if we didn't have a table and a graph to plot, then how would we do it algebraically? How can we find an equation for it? That's going to be using the same steps. So instead of writing f of x is equal to 2x cubed minus 1, we're going to have y is equal to 2x cubed minus 1. And what we're going to do is we're going to swap the positions of the x and the y. So now that we have this, we need to isolate y. We need to get y by itself. So what we're going to do is we're going to add 1 to both sides. We're going to end up with x plus 1 is equal to 2y cubed. We have 2 times y cubed, so we have to divide by 2 on both sides, giving us an equation like this. Y cubed is equal to 1/2 x plus 1. Finally, the last step is to do the cube root on both sides. That means that our answer should be y is equal to the cube root of 1/2 x plus 1 on the inside. And that should be our equation. Okay, now we need to talk about the domain and range of both of these functions. And the convenient thing about cubic root functions is that the domain and range is always going to be all real numbers, no matter if it's a cube root or the x cubed. So the domain is going to be -infinity to infinity. The range is going to be the same. The domain for the inverse is going to be the same. And then the range for the inverse is also going to be the same. So now if we're asked to compare the domain and range, we notice that they are all the same. If we were to flip these around, we would get equivalent values. So we could say that it is all real numbers for all domain and range. The reason that is because we didn't have to make any type of adjustments on any of the functions so that we can make it technically a function by definition. So what we'll write is no adjustments were made to the functions. The last example we're going to go over is this one. So we have a square root function of f of x is equal to 3 times square root of x plus 2 minus 1. So we need to create a table for it, which means we just have to plug in the x value and then we'll find its inverse. So we're kind of going the other way around. We started with a quadratic function, and then we found its inverse, which was the square root. And now we're going the other way around to see what kind of difference we'll have. So whenever we plug in that x value, we're going to have negative 2 plus 2 minus 1. So that means the inside term is going to cancel out, so we're just going to be left with minus 1. Feel free to go through the arithmetic slower if you need to, but if you don't need to, then that's fine. So now we're going to plug in negative 1 into this equation. So minus 1 plus 2 is going to be 1. Square root of 1 is 1. Times 3 is 3. Minus 1 is 2. So now that I plug in 2, let's see what we get. We're going to have 2 plus 2 minus 1. So 2 plus 2 is 4. Square root of 4 is 2. Times 3 is 6. Minus 1 is 5. And then my last one, I'll plug in 7. So 7 plus 2 is 9. Square root of 9 is 3. 3 times 3 is 9. Minus 1 is 8. And again, we're just going to flip the x's and y's, giving us new points of, let's see, negative 1, 2, 5, and 8. Then we're going to have negative 2, negative 1, 2, and 7. And this is because we just flipped the x and y's like how we've been doing. So these are the inverses. All that's left to do now is graph them. So I'm going to graph the parent function, the main, or not the parent function, but the main function in blue. So we're going to have negative 2 comma 1, or negative 2 comma negative 1, which starts down here. Negative 1, then 2, then 2 comma 5, and then 7 comma 8. So we get a big function that grows like this. Now let's see what we get when we graph the other one, the inverse in red. Be sure to label it. I'm just going to call it f of x. So here we get negative 1, negative 2, which is down here. We get 2, negative 1, which goes out here. Then we get 5, 2, goes all the way up here. Finally 8, 7, which goes right here. So the shape looks very good. Really like how the symmetry is followed perfectly upwards. We end up with symmetry like that. And notice how even though we expect to see a quadratic function as the inverse, it does not graph that way. Since it doesn't graph that way, we're going to have to make sure we note that in the range and domain appropriately. And we'll see what that means exactly once we get to it. But anyways, we're going to find the inverse algebraically, which means we need to swap the f of x with y. X plus 2 minus 1. Then once we have this, we're going to swap positions. The x's and y's are going to swap positions. So now we have x is equal to 3, y plus 2 minus 1. So in order to get y by itself, we have to add 1 to both sides, giving us x plus 1 is equal to 3 square root of y plus 2. And the 1's over there canceled out. Now we have 3 times all that, so we got to do division. So I'm going to divide. Cancels out that 3. And now we are ending up with 1 over 3, x plus 1. All of that is going to be equal to square root of y plus 2. So the opposite of square root, the inverse operation, is going to be squared. So that means we need to square everything. So once we do that, I'm going to rewrite everything up here. We end up with y plus 2. That's going to equal to, everything gets squared, so that means we're going to have y, or 1 squared over 3 squared. Then we're going to have x plus 1, and all that's going to be squared. The last step is just to subtract by 2 on both sides. So we end up with y is equal to Well, 1 squared over 3 squared is going to be 1 over 9. And that x plus 1 squared stays the same, and then we end up with a minus 2 on the outside. So there is our inverse function. And now when we check out the domain and range, we notice something very interesting. So the domain for the function, actually there is a typo here. It is not for this function. It's going to be for 3 x plus 2 minus 1. So the domain and range for that function, so the furthest point on the left is -2, and then it goes off to infinity. Talking about this one right here. The lowest point is -1, and it goes up to infinity. And now when we're analyzing the domain and range, we notice that this time it is perfectly flipped. So the furthest point of the inverse, which we are talking about right here, we have that it is -1 on the left all the way to infinity on the right. And the lowest point on the range is -2, and the highest is infinity. So if we take a look at this, we notice that the domain and ranges flipped between the inverse, or between the function and the inverse. And the reason there's no inequality with the domains and ranges is because we had an f of x is equal to the 3 square root x, or square root 3, yeah, so we have f of x is equal to 3 times the square root of x plus 2 minus 1 first. So that means we have to make the domain and range restriction for the parabola. Normally when we have a function like this, we have another side like that, and we have a parabola on both sides. But since we started with the square root function, we do not do that. We have to match up the domain and ranges appropriately. Okay, so now that we have that, let me just get started on one of the homework questions. So just so you guys know my expectations, I want you guys to make a table for the function right here based on some points you see, maybe right here, maybe right here, maybe this one, maybe this one up here, maybe others if they're a good approximation. And I also want you guys to make a table for whatever is going to be your inverse. So that's probably just going to mean you're going to flip your x's and y's. But besides that, just practice your algebra. Make sure you know how to solve for any given variable, no matter where it is in the equation. And remember your inverse.